Now, we want to discuss another beautiful theorem in matrix, which is called the transpose of a matrix. Now, in transpose of a matrix, what we do basically is to interchange the rows and columns. All right, so the first row becomes the first column, the second row becomes the second column, the third row becomes the third columns, and it continues like that. And now it is denoted by A transpose, A and transpose. Now, let's look at this illustration. If we have A to be equals to AB, CD, AB is the first row, CD is the second row. Now, in transpose of a matrix, we are interchanging the rows with the column. So the first row becomes the first column. Can we see that? AB, which is the first row, becomes AB, the first column. And CD, which is the second row rather, becomes CD, which is the second column. Okay, and we can also look at it as this: AC, which is the first column, becomes AC, which is the first row. And likewise, BD, the second column, becomes BD, the second row. Let's take an example. I have A to be equal to 1, 2, 3, 4. Now, A transpose is equal to what? The first row becomes the first column, 1, 2. The second row, 3, 4, becomes the second column, 3, 4. Let's take another example. I have B to be equals to 2, 7, 6, 1, 2, minus 4. And now let's look at B transpose now. B transpose means this is 2, 1 is the first column, or we go by the row, whichever way you prefer. Let's try the row now. The first row becomes the first column, so this means this is 2, 7, 6, and the second row becomes the second column, 1, 2, minus 4. Or if you want to go in the direction of the row, the column becoming row, so this is the first column, 2, 1, and it becomes the first row, 2, 1. The second column, 7, 2, becomes this second row, 7, 2. And the third column, 6 minus 4, becomes the third row, 6 minus 4. Now, the beautiful of transpose of a matrix is that the order is being mirrored. So let's take, for instance, I have A. In the first example, I have A to be 2 by 2 matrix, and now A transpose, so this is being interchanged like we did earlier. So this is being interchanged for this, which will result into a 2 by 2 matrix. Now let's try and make this a little bit more sensible. So I have 2, okay, by 2 matrix. However, the A transpose now is being mirrored such that the row number becomes the column number. So this will become a 2 by 2 matrix. Now for B now, let's take a look at B. B here is a 2 by 3 matrix. Okay, a 2 by 3 matrix. 2 by 3 matrix. Let's look at that. 2 by 3 matrix. And now B transpose now is being mirrored. Alright, so the column number becomes the row number, and the row number becomes the column number. So this means we have a 3 by 2 matrix. And now if you look at this now, the B transpose here is a 3 by 2 matrix. So let's take one more example on this. Let's say number 3. And here in this case I have A, or let's say C now, following the order. C is 0, 0, 1. C transpose therefore is equal to what? Yes, you guessed right. 0, 0, 1. This is a 3 by 1 matrix, and the C transpose here is a 1 by 3 matrix. We can see a mirroring of the order. Now, let's look at how we can incorporate transpose of a matrix with matrix operations.